What if you could compress billions of years of geological evolution into just a few days? Witness the impossible. From common carbon to the world's most desired treasure. This is the godlike power of high-pressure, high-temperature technology. Nature takes a billion years to create a diamond, but science has found a way to bridge that gap. It all starts with a single seed, a tiny fragment of carbon that holds the blueprint for brilliance. In its raw form, carbon is just graphite soft, dark and humble. To change its destiny, we use the HPHT process, high pressure and high temperature. This massive press is designed to recreate the crushing weight of the Earth's mantle. Inside this chamber, we are about to simulate conditions 100 miles below the surface. A catalyst, often a mixture of iron and nickel, is added to help the carbon dissolve. The temperature is raised to a staggering 1500 degrees Celsius. At this heat, the strong bonds of the graphite begin to fail and melt away. The carbon atoms are now free, suspended in a molten metallic sea. But under immense pressure, they seek a more stable, rigid structure. We exert over 5 gigapascals of pressure, forcing the atoms to reorganize. One by one, the carbon atoms attach themselves to the diamond seed. They follow the crystalline pattern, building a lattice that is the hardest known to man. This process requires absolute precision and can last for several weeks. Computers monitor every micro change in environment to ensure the diamond's purity. The energy contained within this machine is equivalent to a volcanic event. Any fluctuation in temperature could lead to flaws or cracks in the crystal. We are literally rearranging the building blocks of matter in real time. As the growth cycle nears completion, the temperature is slowly lowered. The pressure is released with extreme care to prevent thermal shock. What emerges is a rough diamond, born from human ingenuity and extreme physics. Every stone is unique, possessing the same chemical fingerprint as a mined diamond. Advanced spectroscopy is used to verify the atomic perfection of the stone. Now, the transition from industrial product to precious gemstone begins. Laser technology allows us to plan the cut with sub-millimeter accuracy. We maximize the light return by following the natural physics of the crystal. The polishing process uses diamond dust to grind the facets to perfection. It is a delicate balance of heat, friction, and artistic skill. The result is a stone that captures and bends light with breathtaking fire. Visually, even an expert gemologist cannot tell it apart from a natural diamond. It is pure carbon, crystallized into a symbol of eternity. This method is more than just manufacturing. It is the evolution of a craft. We can now produce diamonds for both jewelry and advanced industrial use. The HPHT process offers a sustainable and ethical alternative to traditional mining. Each stone is laser inscribed to ensure full transparency for the consumer. From the depth of the lab to the height of luxury, the journey is complete. We measure success not just in carats, but in the precision of the science. Look closely at the brilliance. You are seeing the result of mastered physics. The HPHT diamond, a masterpiece of pressure, heat, and human vision. By removing nitrogen, we can create diamonds that are even more colorless than those found in nature. However, controlling impurities allows us to create rare colors, like deep canary yellows. Post-growth treatments can further refine the stone's atomic clarity. Some diamonds undergo irradiation to achieve vibrant blues or greens. The cooling process is a slow, methodical dance of thermodynamics. We aim for flawless or internally flawless ratings at the molecular level. The equipment must withstand forces that would crush a tank like a soda can. The metal solvent acts as a medium, allowing carbon to flow toward the seed. This industrial process requires a massive, stable energy supply. Science provides the proof. Raman spectroscopy confirms the 1,332 centimeter peak. It is the same element as coal, but with a structural strength that is unmatched. Extreme heat requires extreme cooling for the surrounding electronics. Modern technology allows for batch growth, producing multiple stones at once. Once removed, the rough stone is cleaned of all metallic residues. Managing the temperature gradient is the secret to a perfectly clear crystal. Transparency is key. Every stone is marked for its laboratory origin. When light enters, it slows down, bends, and explodes into a spectrum of color. Each diamond is categorized with scientific rigor. Type 2A diamonds, the rarest in nature, are the standard in our lab. Beyond beauty, these diamonds power our most advanced industrial tools. HPHT technology is also used to explore the physics of planetary cores. Because diamonds conduct heat better than any other material, they are vital for the future of computing. Designers can now work with high-quality stones that were once prohibitively expensive. The hearts and arrows pattern is the hallmark of a masterfully cut stone. Its refractive index of 2.42 remains the gold standard for brilliance. Third-party grading ensures that every claim of quality is independently verified. The final setting is where science meets the timeless art of the jeweler. We are working with pure isotopes to create the most perfect crystals imaginable. As the cycle ends, the silent pressure of the lab yields a treasure. The octahedral shape of the rough stone is a testament to its cubic growth. Magnetic fields are sometimes used to align the growth of the crystal. High-pressure hydraulics are the veins and arteries of this technological giant. Specialized ceramic insulation protects the machine from the sun-like heat within. Nothing can scratch a diamond except another diamond. The market is shifting toward choices that protect both the earth and the consumer. When you look into the stone, you are looking at the pinnacle of human achievement. Light travels at 186,000 miles per second, but inside the stone it performs a complex ballet. Electronic testers confirm the thermal and electrical conductivity of the diamond. Some HPHT diamonds exhibit a unique glow, a secret signature of their origin. From the lab to the finger, every step of the journey is recorded. We use renewable energy to ensure the process is as clean as the stones themselves. Boron introduction creates the rare and coveted fancy blue diamond. Understanding crystal systems allows us to manipulate the very essence of matter. Its brilliance is so high that it outshines every other gemstone in existence. Even the smallest stones receive the same level of scientific care. Software-driven planning ensures we don't waste a single milligram of the rough. The final polish brings out the adamantine luster unique to diamonds. It is a gift that represents the strength of a bond and the power of innovation. From a piece of graphite to a brilliant star, the transformation is complete. This is the HPHT diamond. Perfect by nature, perfected by science.